Yes. If also,
Respected Chief Guest, Honorable Director, Principal, Head of the Department, esteemed dignitaries, distinguished resource persons, dear faculty members and participants, good afternoon, one and all. On behalf of CSM Department, it gives me immense pleasure to welcome you all to the inauguration ceremony of the Faculty Development Program on Generative AI and Large Language Models for Teaching, Research, and Industry. We are living in an era where artificial intelligence, particularly generative AI and large language models, has transformed the way we teach, conduct
పేపర్ పట్టుకొని
research,
వెళ్ళిపోయినట్టున్నారు
and
చూడు
engage with
ఓపెన్ లేదండి
industry. These
కనుక్కున్నాను ఫాస్ట్
technologies
చేయండి
are powerful
ఎంతసేపు
tools
ఇష్టమవుతే
actively shaping education, innovative, and decision making across the globe. Now we
ఎంతసేపు
proceed to the lighting of the ceremonial lamp, a symbolic gesture to invoke knowledge, wisdom, and enlightenment. I now invite our Chief Guest Director, Principal, esteemed dignitaries for this age old ritual of lighting the lamp. Thank you, dear dignitaries, for inaugurating this ceremony. May this light guide us toward wisdom, clarity, and purpose. To invoke the blessings of the Almighty for the success of this program, we pay the gratitude with this prayer song.
ఓన్లీ వీడియో వస్తుంది. అవట్లేదు. అవట్లేదు. అక్కడ
It is my great honor to invite our head of the department, Dr. MVP Chandrasekhar, a pillar of strength and constant encouragement to our faculty. I request him to kindly address the gathering.
Thank you, madam. Good afternoon. It gives me an immense pleasure to warmly welcome respected dignitaries, our Honorable Director, Professor V.V. Nageswarrao Garu, our Principal, Dr. A.S. Srinivasarao Garu, and Program Chair, Dr. Amir Junaid Ahmed, Secretary, AMIEE Association, all the participants, distinguished resource persons, and esteemed faculty members to the 5-day online faculty development program on generative AI and large language models for teaching, research, and industry, organized by the Department of Artificial Intelligence and Machine Learning, Aditya Institute of Technology and Management, TechAli, from 19th to 23rd January 2026 in association with AMIEE. This faculty development program is conceived in response to the rapid advancements in generative AI and large language models, which are significantly transforming teaching learning process, research methodologies, and industry practices. The program is designed with a strong emphasis on practical exposure and live demonstrations, enabling the faculty members to effectively integrate AI-driven tools into pedagogy, research, and professional workflows. Through this FDP, the participants will gain hands-on familiarity with widely used and emerging AI tools for content creation, assessment design, personalized learning, research support, and productivity enhancement. This initiative also aims to promote ethical and responsible adoption of AI in academics while supporting the outcome-based and learner-centric education. We are honored to have a panel of eminent academicians and researchers from reputed institutions across India as a resource persons whose expertise will greatly enrich the deliberations and learning outcomes of this program. We sincerely thank our management, Professor V.V. Nageswarrao Garu, Director Sir, and Principal Sir, Advisory Committee, conveners, coordinators, and organizing committee for their constant support and dedicated efforts in organizing this FDP. We are confident that this program will be highly beneficial and intellectually rewarding for all the participants. Once again, we extend the hearty welcome to everyone and wish the FDP a great success. Thank you. Over to Sangeeta Madam.
Thank you, sir, for your informative and motivational speech. It is my great privilege to invite our principal, Dr. A.S. Srinivas Rao, an outstanding leader. His unwavering commitment and profound dedication is the key to the success and growth of our institution. I request him to propose welcome address. Sir, please.
Good afternoon. Thank you for the invitation. Myself, Dr. A. Srinivasarao, principal of this institute, Aditya Institute of Technology and Management. I am great and honored to deliver my voice on this FDP. So it was a great initiative by the our college and Department of CSM and as well as the AMIW society. This is one of the society recently launched and for the improving the mainly AMI technologies around the faculty members as well as the researchers. Okay. So in this regard, first I congratulate all the program coordinators as well as the co-conveners as well as the coordinators and organizing committee. Mainly, we are appreciate the efforts of the program chair, Dr. Amir J. Ahmad for granting a FDP program to our college. Already we know that. So today artificial intelligence technology is becoming very important tool for in all applications, mainly in the teaching learning process also. So therefore, this FDP mainly focused on the teaching learning process, mainly by using the generative AI and large language models for the teaching and research and industry. So this FDP program may be helpful for the enhance the skills of the faculty members to improve their teaching skills, either teaching skills or the valuation skills or R&D skills, whatever it may be. So this gives a good platform as well as gives better input to the faculty members to enrich their skills. So mainly I appreciate all the speakers and thankful for all the speakers also for giving their elaborations in this FDP. I hope that this FDP successfully completed, will successfully completed and give the better platform, give a better platform to various discussions among these all the teaching skills, and finally it will be ended with a successful one. So thank you one and all for giving the opportunity.
Thank you, sir, for your support and inspiring speech. It's my profound privilege to invite Professor V.V. Nageshwar Rao, Director, Item College, a visionary leader, an able administrator, and a guiding force in shaping the growth and values of our institution. I now request him to kindly address the gathering. Sir, please.
So, good afternoon to all. So I'm happy to be here in the inaugural session of a 5-day faculty development program on artificial intelligence and large learning modules for teaching, research and industry. So it was supported by AMIEE and Secretary Dr. Amir Junaid Ahmad Garu for his support and cooperation in making this FTP to ground. And also, I congratulate the convener, Mr. Dasaratha, and the Department of Artificial Intelligence and Machine Learning, headed by Dr. Amibi Chandrasekhar, and all other faculty members. So nowadays, as already speakers mentioned about the importance of this one, now it is gaining a lot of popularity and momentum, the development of application of AI tools in various areas. Now also, based on that only, from the current academic year, that is 25 academic year onwards, we are integrating the all core branches also with the AI, and we introduce around 5 subjects in every department, including civil, mechanical, electrical also, particularly to improve the efficiency in the teaching learning process and skills also. And nowadays, particularly the efficiency of any outcome will improve using the AI tools. And first of all, that the faculty should understand where to use the AI tools and what type of tools are required. And along with the theoretical, but also we need the practical approach. I hope this FDP, 5-day FDP, will not only give some tools that are widely available for teaching learning process, particularly the development of the content and also assessments, and also what it called as preparing the various fine tune the some of the personalized learning, research support, and academic planning also. Now, many external vendors also coming to give the training. After all, we are a technical institution. We have the enough resources and talent. So that's why we want to try to familiarize the AI tools to all the faculty members of our institution and also nearby institutions. And we are conducting the various programs on this. And this is the one among the various programs, particularly to familiarize the AI tools and application of the AI, how to use the AI tools, particularly for resource generation, content generation, and assessments also. And hands-on experience should be given in this one, because theoretical knowledge will anyhow sub will be there. But in addition to the theoretical, but also these FDPs will also give some hands-on experience, particularly to the application of these AI tools in our various, to get the required outcomes. Particularly, mainly the objectives of this program is familiarize the faculty members with key generative AI and LLM tools, and demonstrate AI tools for content creation, assessment, and engagement, and to provide the hands-on exposure to the tools that enhance the research and productivity, and to support the integration of AI into outcome-based and learner-centric pedagogy. So these are the objectives of this program. I hope with this 5 days program, we are able to fulfill these objectives, so that we'll get the desired outcomes. And eminent resource persons are there, around 10 eminent resource persons are there. I'm thankful to them for their acceptance in participating in this particular event and delivering their skills and knowledge to the faculty members. Definitely, the application of these AI tools will really enhance the skills. But the same thing that we should tell them that we should not completely depend on these tools, but we have to use this as a tool to refine, to speed up, to improve the efficiency. So I thank the AMIEE for their support, and all the resource persons come in from the various institutions, including from Delhi, Mohan Madharal University, Daulat Ram College, and Coimbatore Institute of Technology, NBKR Institute, and KJ Soumya Institute, and from Bharati Vidyapit College of Engineering, Dayanand Sagar College of Engineering, and so many institutions are there. I thank, I can't name by name, but I thank all the resource persons for their presence in this workshop. And I congratulate the Department of CSM and convener and co-conveners. And I hope this 5 days program will give an edge to the participants over the others. Thank you very much for giving me this opportunity. Thank you.
Thank you, sir, for your inspiring and invaluable insights. Your vision sets a strong foundation for the days ahead. We are honored to have amidst us today's chief guest, Dr. Amir Junaid Ahmad. Thank you, sir, for your presence and accepting our invitation to grace this occasion. Dr. Amir Junaid Ahmad is an academic leader, entrepreneur, and ecosystem builder with an extensive experience in innovation, technology, and industry academic collaboration. He is the managing director of AMI EE Association and founder of multiple initiatives focused on student employability, research mentoring, leadership development, and global exposure. His expertise spans artificial intelligence, machine learning, innovation management, startup ecosystems, FTPs, academic conferences, and international collaborations. A TEDx speaker, Forbes listed professional, and Times Excellence Award recipient. He has delivered keynote talks at prestigious national and international institutions, including IMI's University of California, SRCC, LSR, and University of Delhi. Under his leadership, AMI has grown into a global network of over 4,000 academicians and industry professionals, fostering international academic partnership. I welcome you again, sir. Thank you for your presence, sir.
Thank you very much, ma'am, for this wonderful introduction. Respected dignitaries, Honorable Chairman and Management of Aditya Institute of Technology and Management, respected Director, Principal, Head of the Departments, esteemed resource persons, dear faculty members, researchers, and participants, ladies and gentlemen. A very good afternoon to everyone present here. It is indeed a great honor and privilege for me to be part of this 1 week online faculty development program on generative AI and large language models, which will be used for teaching, research, and industry. This is being jointly organized by Aditya Institute of Technology and Management and the AMI Association. And I'd like to congratulate the Department of CSM, Aditya Institute of Technology and Management, the convener, co-convener, coordinator, especially Professor Dasaranda. He has been instrumental. We have been in touch for almost more than a month, and this is the successful execution is because of his effort and the entire organizing committee for the conceptualizing and executing a program that is highly relevant, future-oriented, and impactful. We are living in an era where artificial intelligence is no longer a future technology, it is a present reality. And generative AI and large language models are redefining how we teach, learn, research, innovate, and work. Today, educators are not just knowledge providers, they are facilitators of learning in an AI augmented world. Researchers are expected to be faster, more interdisciplinary, and more impactful. Industry experts, graduates who are AI literate, ethically grounded, and innovation ready. This FDP is timely because it does not merely talk about AI in theory, it focuses on teaching enhancement, research productivity, industry relevance, ethical and responsible use of AI. I'll take some time to give a very brief introduction of AMI Association. AMI is a professional and academic body committed to advancing artificial intelligence and machine learning, innovation and entrepreneurship, engineering excellence, industry academia collaboration. We work as a bridge between institution, industry, researchers, and policymakers through the faculty development program like this. We also conduct national and international conferences, and the best of the papers are we try to get them published in SCI journals, Scopus journals, and other reputed journals. We also help researchers, mentoring, and editorial opportunities in many of our own journal and the associated journals with the AMI Association. We have student chapters and innovation ecosystems, and we also have global academic collaborations. Today, AMI has a strong and growing network of members from IITs, IIMs, reputed universities, and industry, including head of the departments, deans, directors, and very senior professional from the industry. Recently, we have expanded our international academic footprint through collaborations with university in Thailand, and we are actively working with institutions in Malaysia, Maldives, and USA. This international collaboration will enable faculty and student exchange programs, joint research initiatives, global immersion and AI programs, international FDPs, and conferences. One very important aspect rather, is I wish to highlight here is especially for academic leader is that AMI supported FDPs are not just standalone events. They contribute meaningfully to faculty upskilling, research output, interdisciplinary exposure, outcome-based education, institutional quality benchmarks. Such activities directly support NAC, NBA, and global accreditation frameworks, strengthening institutional profiles in faculty competencies, research culture, industry engagement, innovation, and entrepreneurship. This FDP has been thoughtfully designed in collaboration with the conveners and the coordinators of Aditya Institute of Technology and Management Department of CSM to ensure conceptual clarity on generative AI and LLMs, hands-on exposure to AI tools and prompt engineering, academic applications such as assessment design, literature review, and supervision, industry use cases, including automation and workflow optimization, ethical and legal and societal considerations, innovation, and entrepreneurship perspectives. With a distinguished panel of speakers from NITs, Central Universities, Delhi University. Today, only the first session is of Dr. Rita ma'am. She is from Delhi University. And we have a reputed resource person from other reputed institutions. Participants are assured of high quality learning and rich academic interaction. I would like to encourage all participants to engage actively in discussions, ask questions without hesitations, experiment with AI tools responsibly, think beyond your discipline boundaries. Remember, AI will not replace teachers, but teachers who use AI will lead the future of education. Once again, I sincerely thank the Aditya Institute of Technology and Management Leadership, the Department of CSM, and the entire organizing team from this collaboration. On behalf of AMI Association, I reaffirm our commitment to supporting institutions, empowering faculty, enabling students, building global academic ecosystems. I wish this FDP great success, meaningful outcomes, and long lasting academic impact. Thank you for your kind attention. Jai Hind. Thank you.
Thank you, sir, for your inspiring words. And we wish that we will incorporate with you in future also, sir. I would like to express my sincere gratitude to our respected director, principal, head of the department for their visionary leadership and constant support which has made this FDP possible. I thank all the participants for showing an immense interest in this FDP. I'm confident that this program will highly beneficial and will contribute significantly to the professional growth. We are fortunate to begin this program with a distinguished resource person. It is a proud privilege to introduce and invite our esteemed speaker, Dr. Rita Rani. Dr. Rita Rani is an associate professor of economics at Daulat Ram College, University of Delhi, with more than 18 years of teaching and academic experience. She holds a PhD in economics and has qualified the prestigious UGC NET exam. Her areas of specialization include development economics, Indian economy, environmental economics, research methodology, and public economics. She has an extensive publication record comprising journal articles, book chapters, and edited works, with recent contributions focusing on AI in education, sustainability, digital finance, inequality, and economic development. Dr. Rita has held several administrative and leadership roles, including teacher in charge, NSS convener, and committee coordinator. She is actively involved in research projects, FDP's national and international conference, and is a life member of multiple professional bodies, including AMI. I now invite Dr. Rita Rani to kindly take over the session and enlighten us with her expertise knowledge. Ma'am, please.
Hello, good afternoon, everyone. Let me share the
Good
screen
afternoon,
first.
ma'am. Good afternoon.
Good afternoon, ma'am.
Good afternoon, everyone.
Good afternoon.
Is my screen visible?
Yes, ma'am. Yes, ma'am.
ma'am.
Visible.
So, good afternoon, everyone, and a warm welcome to you all. So, I first of all would like to congratulate the organizers for organizing this informative and very detailed and for a big concept they have taken as the FDP, because nowadays many of the uh, technologies are emerging and generative AI is leading all those technologies. So it becomes important for us to be on the on the front side, and being the teachers and faculty, we have a greater responsibility to learn about generative AI or the latest technologies and to teach these technologies to the new generation. So let us start. I'll be starting this presentation uh, with the permission of the organizers. So I am delighted to have this opportunity to be here with you today. We are living in a time when technology is no longer just supported our work, but actively shaping how we think, create, and communicate. So, in today's presentation, we will explore generative artificial intelligence, what it is, how it works, and why it is becoming such a transformative force across education, research, and everyday life. So let us start this presentation or this session today. So to understand generative AI, first of all, we have to understand the difference between generative and non-generative AI. Non-generative or traditional AI analyzes data for prediction and decision making based on the information provided to it. For instance, blood tests for medical diagnosis for diabetes, cancer, yeah, I was telling, for instance, the blood test for medical diagnosis for diabetes, cancer, etc., and using X-ray for investing other ailments. It is also used for tasks like fraud detection. I hope I'm making sense in clearing the difference between non-generative and generative AI. Okay, so non-generative AI was based on the samples taken. Like I'm telling you about the blood test. Okay, earlier blood test used to be there to diagnose the diseases. So these diseases, and the X-ray, it means we are feeding some input first, then we are getting the output, and those output mostly they were the decisions. Like in medical science, we are taking decision about the disease. Okay, and these type of technologies, these were non-generative AI. Okay, so uh, non-generative AI focus on accuracy, efficiency, and decision making rather than creativity or content generation. While generative AI generate new content, it generates new data based on training samples. It can generate images, text, audios, video, music, and voice as output. So I hope this should be clear now. Non-generative is where we are feeding input and getting output, and there is not that much creativity involved from the side of the technology, and it is just giving us results. Okay, but generative AI is a creative thing. It is creating something that the earlier technologies were not able. So next comes, let us explore now the generative AI, and I believe that the difference between generative and non-generative is clear to you. If it is not clear, you can put your questions. Okay, I'll take those questions. Next is the what is generative AI. So generative AI refers to system that create new content, that is text, images, music, code, or video based on vast data sets. Basically, these all systems learn patterns from big piles of human made data, then remix those vibes to create fresh content that feels original. Tools like ChatGPT write essays or jokes, Dell-E dream up wild images, and stuff like Sora even makes short videos. It is supported by clever brain-like networks and predict what comes next. Okay, so unlike traditional AI that just recognize, classifies, or predict, the generative AI actually creates. It learns complex patterns from massive data sets and produces original human-like content from conversational chatbots and computer code to stunning visuals, art, music, and videos. In short, generative AI is transforming how we create, communicate, and innovate in the digital age. So, let us learn what is the concept of AI. Now, what is the concept of AI? So, generative AI is is evolving. Okay, so artificial intelligence was already there. As I told you, in the past time, we had the technology of taking x-rays. We have the technology of diagnosing diseases with the help of machines. That was also the AI, but later on it gradually improved, and after that came machine learning. Okay, in past few years we have learned about machine learning, where the machine was able to learn and to give results. After that came deep learning, and finally came the generative AI. So we can say generative AI is a subset of deep learning. Deep learning is based on various type of neural networks. uh, so this I can say this all game of generative AI is based on these neural networks. And neural networks, I'll be taking these neural networks in the next slide, but I would like to tell you that there are so many type of neural networks that are used or that has been created time to time to improve the workability or the efficiency of the generative AI. So these are the ANN, like artificial neural network. Next is CNN, convolutional neural network, recurrent neural network, reinforcement learning, then generative adversarial network, then long short-term memory. So all these type of neural networks coming time, gradually improved the working of the technology, and they improved the total scenario of AI. Okay, so first of all, we must understand what is the neural network. So neural network model is inspired by how human brain works. It consists interconnected units called neurons that process information by passing signals to one another. Okay, like in human brain, there are so many type of neurons are there, and they connect with each other, and then we are able to do our task, or anything that we want to do. We can take decision, and similarly these neurons, this neural technique has been incorporated or adopted for the functioning of AI. So in simple terms, neural network learns by recognizing patterns in data, such as word in sentences, features in an image, or trend in numbers, and then uses those patterns to make predictions for generating output. So let us see the building foundations for this generative AI. So after the early creative experiments, like I told you about in the medicines, and before that calculator we have used for a very past long time. Calculator we were using, all these were the uh, AI. So after the early creative experiments, AI entered a phase where mathematics became central. This was the time when expert systems dominated. Okay, and in 1980s, rule-based expert system encoded human knowledge for tasks like medical diagnosis. They worked well in narrow domains, but lacked creativity and could not generate truly novel solutions. So these rule-based system was like when we were putting some that rule-based system. You can understand this like a input output model, and it was based on the binary coding. If you remember, in the starting of when we started using computer, and we were giving if then conditions to form some task, and these if then conditions were like the coding or the input for the computer or the AI, then it was able to generate the output. So this system was lacking the creativity and could not generate truly novel solution. Then in 1990s, the probabilistic revolution came. Models like Markov chain, hidden Markov model, and Bayesian network allowed AI to handle uncertainty. This revolution was important because these models could predict and generate sequence, enabling machines to create patterns rather than just follow the rules. Then in the late 1990s, and early 2000, neural networks matured. Improved backpropagation algorithms and rising computational power made multi-layer networks viable for pattern recognizing. By the year 2000, the foundations were uh, yeah. By the year 2000, the foundations were complete. strong mathematics, better algorithms, and computing computing infrastructures, setting the stage for the deep learning revolution behind modern generative AI. So next, let us see what are the neural networks and how many type of neural networks are there. So the deep learning after this phase, like the foundation was completed in 2000, and then the deep learning came with the neural network revolution. The whole world of generative AI revolves around the neural networks. These are the various type of neurons that came into existence gradually. First of all, there came the ANN. ANN is the artificial neural network. It was used for the structured data to get the output. Rule-based system was based on ANN. Okay, this artificial network. ANN, it was used for the structured data to get the output. Rule-based system was, but it was not able to process the complex data. Okay, as you can see in first layer we give input, then there are some hidden layers. You can imagine this with the human brain neurons, and these are the same thing, that there are so many neurons in the human brain, and those neurons connect with each other and then they give the result. So these are some many of the hidden layers which connect to each other and they process this input and then give output. This is the same thing that has been that was tried to be mimicked by the AI. Okay. Then next invention was of CNN, that is convolution neural network. It was able to process the complex data, structured data, numeric feature, regression, etc. It performed feature extraction by using various layers, different filters, and pooling. Okay, so this is the convolution neural network, and you can in this you can say there are different type of layers, and those layers were able, and with the help of these layers, the complex data was also able uh, uh, to be uh, processed and get the output. Next, in 1982, recurrent neural network were developed, allowing machines to learn sequences such as sentences or time based data. Sequence data can be understood as a storyline. I hope this is clear what is sequence data, where the data is connected to each other. If you change the sequence, then obviously the meaning of data would change. For example, you can take a storyline. Okay, if you change the sentences, if you change the words, then obviously the meaning of a story or the system of story would change. So this sequence data can be if you this recurrent neural network was able to run the sequence data, and it was very much helpful and it worked. Like you can see, there are many loops here. Okay, in hidden layer 1 there are different layers, hidden layers, and these hidden layers, they were doing, they were creating a loop. Okay, once as I'm telling you, there are different sequence, and these data were processed in the sequence. Once our first step is done, then it will go back to the second step, it will go back to the third step, and in this way the with this loop creation, the data will be processed and finally reach to the output. Okay, then RNN, this is the recurrent neural networks. It worked with feedback loops in hidden layers. Whatever output we get from hidden layer, it's sent back to hidden layer again until it complete the time strength. But the time strength. Okay, but the problem with the RNN was that it had a short-term memory. It was not able to hold a big data. There was a dependence. Okay, so whenever there was big data, and if you feed a big large sentence, then it become confused and it will give weird results. So this was the problem with RNN. So obviously there was a need for some better technology or the better system. Then came the RL, that is reinforcement learning model, in which the data processed between the agent and the environment until it gets the accurate result. As you can see, there is one agent and another is the environment. So the state is feeding data to the agent, and agent is processing it and taking some action and sending to environment. If this is a good result, then this environment will send the data to the state, and if it is not good, then the environment will send data again to the agent. So this was the process, and agent will again process this. So this was the this is like reinforcement learning, where the actions are reinforced again and again, so that the agent could create the correct result, and it will have to create the correct result, and until it is correct, the environment will keep sending back the results to the agent. Okay, so this was the way, and this was a learning model, reinforced learning. So uh, next is next technology that was emerged. It was emerged in 1997. LSTM architecture was introduced. LSTM was a long short term memory. Okay, long short term memory, and as I told you in the last slide, this recurrent natural neural network, or all these networks, they were not able to run the large data or large sentences. Whenever the data is very large, all these neural networks, they got confused and give weird results. So that's why next came this LSTM model. This LSTM model or architecture, this had the capacity to sustain large data. Okay, so this problem of small data has been improved, and this LSTM network solved the problem of remembering information over long period, making it possible to generate coherent text and music. It helped machines remember information over long period, and it was able to process the complex data. Then in 2014 came the major breakthrough when Ian Goodfellow introduced. Okay, so this Goodfellow introduced GAINS, that is generative adversarial network, where two neural networks compete with each other, that is the generator and the discriminator. Generator creates fake image while the discriminator tries to identify it is real or fake. Okay, so I'll be taking this concept of GAN in the next slide in some detail. So first you have to understand that GANs was working with the two tools. First is the generator and the discriminator. So the generator is creating some synthetic data, then sending to the discriminator, and discriminator is checking this data whether it is good or bad, or the correct or not correct. Then it is sending back to the generator. Generator is trying to improve this, and then sending again to the so it becomes a loop, and with this flow, the generator and discriminator try to give the correct output. So let us explore further how this gains works. So this is the actual, here you can see this is the actual system of generator and discriminator that we know as the generative adversarial network. Here you can see first some render input is sent to the generator. Okay, then generator creates some sample on the basis of this random input, and mostly this random input you can expect, or you can suppose this like it can be a music, a voice, a image, or text, or anything. Okay, so this is a random input is sent to the generator. Then generator is creating some sample on the basis of this input and sending this to the discriminator. And what the discriminator is doing, discriminator is checking this sample that the generator has sent to it, and it is matching this with the real images, and these real images are already being fed, like whatever technologies are being build up nowadays, they are already having a big large data on which they have been trained. Okay, so here the discriminator checks whether this sample input that has been sent by generator, it is correct or not, or accurate or not. If it is accurate, then this will send to the send as the output, and if it is incorrect, then it will send back to the generator. Then generator will have to create again, and it will send the discriminator and discriminator until it gets the correct output. It will not send it as a input. Okay, so this is known as a back propagation. It is also working like the loop. Discriminator continuously sends back until it get the correct result. Okay, so uh, these these two networks, the generator and the discriminator, compete in a creative duel. The generator creates synthetic data, whilst the discriminator tries to distinguish real from fake. The discriminator keeps sending back the output to the generator until it creates the accurate output. Through this adversarial process, the generator learns to produce increasingly realistic output. Okay, and the capacity and the efficiency of generator also improves with this type of practice. Okay, it revolutionized, this technology revolutionized synthetic media creation, enabling machines to produce photorealistic faces, artwork, scenes, video generation, voice synthesis, and music composition, and even the deep fake technology that are indistinguishable from the reality. This rivalry between generator and discriminator helped transform generative AI. It is now able to produce output from image to image, text to text, image to text, text to image. It can produce one to one data, one to many data, many to one data, and many to many data. Like whatever data you have gathered, whenever we do some imperative studies, we collect data. Suppose you are taking interview of many people, and now you have to compile all these interview into one data. Then this is an example of many to one. So these type of analysis or these type of processing are easy with the help of these GAN networks, that is generative adversarial networks. So here I would like to mention some of the best research paper which helped in development of the generative AI. The first remarkable research paper I came across is the sequence to sequence learning with neural network. This paper was published by Google in 2014. It explained the limitations of classical input output mapping and the problem with longer sentences with that system. It also explained about encoder and decoder technology. The encoder decoder technique proved a foundational approach in artificial intelligence, especially in language translation, text summarization, and generative AI. It is used when one sequence need to be transformed into another, such as converting a sentence into one language from one language into another. So, in simple terms, encoder understands the input and decoder generates the output. The encoder reads the input data from example, a sentence in English, and in converts this input into a numerical representation, then captures its meaning. The decoder uses this representation to generate the output step by step, and we get the translated sentence in other language. So, for example, there is an English sentence, I love learning. Okay, the encoder processes the sentence and understands the context. Then the decoder generates the translated sentence. Like the decoder translate this sentence into Hindi like मुझे सीखना पसंद है. Okay, so this is the system of encoder and decoder. But there were some limitations with the encoder and decoder. The major limitation with encoder and decoder model was that it struggled with the long sentences because all information had to be compressed into a single vector. So if there are multiple sentences or long sentences, then encoder decoder system was not able to perform the task. Okay, so another paper that I can mention here is the neural machine translation with attention. It was published in 2014-15. Uh, it was published by this Badenia in 2014-15. It introduced the concept of attention, this meaning and its need. It introduced the concept of attention, its meaning, and its need. So, what was the problem before attention? As I told you, early neural machines translation system used an encoder and decoder model. But the major limitation was for the long or the complex sentences. Important information was lost, leading to poor translation. So, neural machine translation with attention allows AI system to translate languages more accurately by focusing on the most relevant part of a sentence. Like, it allows the model to look back at all words in the source sentence and assign different importance known as attention weight to different words. Focus on the most relevant words for each translated word. uh, in simple terms, the model asks which part of the original sentence should I focus on right now. For example, in English, we write the book that the teacher recommended was interesting. Okay, so this is one sentence that has been given uh, to this attention encoder and decoder model, that is with attention. Okay, so this is the sentence: the book that the teacher recommended was interesting. So when translating interesting, attention helps the model focus on the book, not on other words. Okay, so this attention helps to give weightage to the particular words like interesting and the book, and then it tries to process the translation. And now the attention is able to handle uh, long sentences better. It improves fluency and accuracy, and it preserves word order and meaning. Finally, attention laid the foundation for the transformers. Okay. Next paper, uh, this is the last but not the least. In fact, this is a most important paper that has turned or revolutionized the whole AI system. So it is a landmark research paper published in 2017 by researchers at Google. Attention is all you need. And it fundamentally changed how modern AI, especially generative AI, works. Okay, as you can see, the authors are Google researchers. Okay, so Google has published this paper in 2017. So this paper introduced the transformer architecture, which showed that AI models do not need recurrence neural network or convolutional neural network that were used in the earlier technologies to understand language. Instead, they can rely entirely on a mechanism called attention. In simple terms, attention allows a model to focus on the most important part of input data when processing information. In the sentence for example, we take a sentence: the student who studies hard passed the exam. So attention helps the model understand that student is related to past, even though they are far apart. Like the sentence: the student who studied hard passed the exam. So in this, student and past are far, not together. Okay, but this system of attention, this understands that student is related to past, and it tries to focus on these two words only. So before 2017, RNN, that is the recurrent neural network, and LSTM, long short term memory architecture, were processing words one by one. Training was at this time, the training of these model were very slow, and long sentences were hard to handle. With transformers, all words are processed in parallel. Okay, and long range relationships are captured better, and training becomes faster and more scalable. So finally, the transformer became the foundation for ChatGPT and other large language models, machine translation, text generation, image and video generation models. So this paper, attention is all you need, proved that focusing on the relationship within data is more powerful than processing data step by step. This makes problems, this makes modern generative AI possible. And this is the transformer model that has been explained in this research paper. So this model says that there is a input embedding and there is a output embedding. So when we feed something as inputs, then it sends it to the multi-head attention, and there is so many type of steps that this output embedding processes, and finally it gives output. So here the neuron system, any of the neural system, they have not been used. In fact, this paper tells that attention is all you need. We don't need the neural system, we don't need the transformers, but we don't need the other LSTM and all tools, but the attention is sufficient to generate the new data. So this was the total technology of generative AI up to now, and we have reached up to this level, and we can expect the further improvement would be there, and we would be able to see some further improvements in this AI system. Next comes, let us see the history of generative AI. Okay, so how I have told about the technology, how it emerged, and let us see the timeline, how the technologies emerged and in what time it has emerged. So the idea of intelligent machine did not start with chatbots and images, right? So as early as 1943, neural foundations were led by McCulloch and Pitts through models of artificial neuron inspired by the human brain and formed the theoretical basis of neural computation and modern AI. In 1950s, Turing asked the revolutionary question, can machines think? So he asked this question, can machines think? And published a paper named Computing Machinery and Intelligence. He also proposed the Turing test and set the philosophical foundation for AI. And next in 1956 at Dartmouth Conference, the term artificial intelligence was officially coined as a field of study. Pioneers like John McCarthy and Marvin Minsky gathered to explore how machines might simulate human intelligence. The early explorations started and the rule-based system emerged. Okay, now the early explorations started and the rule-based systems emerged. uh, uh, that followed human written if then instructions with no learning or creativity. They could perform narrow tasks and could not generate genuinely novel solutions. Though primitive, these systems planted the seeds for machine that could generate new output. Okay, so in 1980s, the learning revolution was like the starting of this learning revolution was from 1980s. Next, these are some early milestone in the AI history uh, that showed machines could do more than calculation. Back in 1960s, AI was just a wild dream, right? AI at Dartmouth conference at MIT, Joseph Weizenbaum introduced ELIZA in 1966, one of the first chatbot. It was able to mimic human conversation using pattern matching, and scripted responses. It was created to act like therapist for medical purpose, and surprisingly, some users believed that they were talking to a real person. It proved that machines could engage in generative interaction even with simple rules. In 1973, artist Harold Cohen created Aaron, okay, and AI program and created Aaron. It was an AI program that autonomously generated abstract and figurative art. So it can be said that AI was already being created. Aaron showed that creativity was not exclusively human. Machines could produce original, visually compelling art. These milestones proved that machines could move beyond calculation and generation, creating novel text, art, interaction that had never existed before. Okay, so next came the milestones in generative AI development. So, after the early creative experiments, AI entered a phase where mathematics became central, and that was the time when expert system dominated. Okay, in 1980s, backpropagation algorithm enabled efficient training of deep neural networks, unlock practical deep learning applications. During the 1980s and 90s, neural network went through a quiet phase and known as the AI winters, when funding and interest declined. So this was the period when you would not find major improvement in AI functioning. Later in 1997, short-term memory network, that is LSTM, solved the problem of remembering information over long period, making it possible to generate coherent data and music. Then came a major breakthrough in 2014 with the Ian Goodflow's introduction of generative adversarial networks. Here, the two networks, generator and discriminator, helped machines generate highly realistic text and media and gave rise to technologies like deepfake. In 2017, the 2017 was the year of transformer breakthrough. Google's attention is all you need paper introduced transformer architecture and revolutionized natural language processing forever. Mainstream explosion came in 2022 when ChatGPT reached 100 million users in just 2 months. Okay, so in 2022, when this ChatGPT came, it was a major breakthrough and it has changed the scenario. Okay, so consumer application in history and it became like fastest growing consumer application in history, and bringing AI to the masses, it transformed how machines process language, enabling context, scale, and creativity like never before. Beyond language, there are some other technologies, those also was thriving. So let us explore core technologies beyond languages, that is image and video generation. Here, diffusion models and gains came as a revolutionary approach to image generations. They use random noise as input and gradually remove it step by step until a clear image or video emerge, while gains rely on adversarial training between a generator and a discriminator. Okay. Models like Del-E, Midjourney, and Stable Diffusion have transformed AI art creation. This enables us to generate stunning visuals from simple text description. Multimodal integration, it was the next breakthrough, and it combines multiple modalities like text, images, audio, video in unified system. Multimodal integration, it was able to generate text to text, text to image, image to text, and image to image. Okay, so this was able to use multiple modalities in unified system. This enables creative workflow where ideas flow seamlessly across different media formats. Next came OpenAI, that is Sora. It's a cutting edge example of multi-modal integration, which can generate highly realistic videos up to 1 minute long from text prompts. This breakthrough opens powerful new frontiers in education, storylining, and content creation. Next, let us see some of the modern giants shaping today's generative AI landscape. So one key example of the major players right now is OpenAI's GPT-4, scaled to roughly 1.76 trillion parameters, showing remarkable gains in reasoning, creativity, and multimodal understanding across text and images. Google's Gemini represents a new generation of multimodal AI. It is designed to understand and generate text, image, audio, and video simultaneously. Then there are open access model like MetaLlama and Mistral AI. They democratize access, allowing researchers and institutions to deploy powerful generative AI locally. All these models align with human expectations through reinforcement learning with human feedback. Okay, so this is the important part, that is the reinforcement learning from human feedback. So this was much needed to align the AI models. For example, I would like to mention here, if you ask ChatGPT, just tell the process to create a bomb. So if this RLHF was not being implemented, it definitely will tell you how to make bomb. Or if you ask any of the, like how to make poison or such things, if you ask these things, then the chat GPT or any of these AI tool, they or Gemini also, they would tell you everything. But after the implementation of this reinforcement learning from human feedback, they are not going to tell you anything. And I have tried it myself. I have put this prompt that how the bomb can be built. Then you can also try. You will found it is giving you, in fact it is advising you not to search about these things, and this is not in your favor as well. So this RHLF made these systems safer. It aligns AI behavior with human values, reducing harmful outputs and improve usefulness and truthfulness. For example, example I have already mentioned. Today's frontier models seamlessly integrate multiple modalities, understanding image, generating text, creating videos, and opening unprecedented creative and research possibilities. Okay, so these are the current landscapes. Next come the future trend in generative AI. So, um, the world of generative AI is changing very quickly. We know this, and major changes that are expected in how AI is customized, how data is created, how energy is used, and how systems work on their own. And in the industry specific AI models are becoming more common. Okay, adoption is expected to grow from about 1% in 2023 to nearly 50% by 2027. These specialized models are designed for areas like healthcare, finance, manufacturing, and law. A synthetic data revolution is also underway. By 2026, around 75% of organizations are expected to use AI generated data. This helps lower data collection costs and makes it possible to train AI. Makes it possible to train AI when real data is limited or sensitive. At the same time, sustainable AI computing is gaining importance. More efficient models and training methods could reduce AI's carbon footprint by about 30% by 2030, making it more environment friendly. And we can also expect that agentic AI system will work independently with tools and people handling complex tasks and greatly improving workplace productivity and decision making. So this agentic AI is a next version of AI you can expect, which not only process the data or give you the output in the form of text, image, video, voice, etc., music, etc., but it also perform your task as an agent. Okay, for example, if you want to travel to some place and you need to ticket your book. So earlier what happened, with the help of AI or even chat GPT, you ask, just tell me or just make my trip plan, and it will be able to make your trip plan. But with the help of agentic AI, you can tell that I want to, you can give the task or prompt like, I want to travel to this place, just check whether it is the time to travel, this is a proper time or this is a correct time to travel there, or whether I would be able to get tickets on time, and what is the cost of tickets, and my passport support, or many of the places uh, uh, do not support all the passports. So all these type of functions, all these type of instructions you can give to agentic AI, and this will perform all the tasks for you. So this is for this example that I give you, the AI will work for the travel, will work as a travel agent for you and do all the tasks that you want to do. So this agentic AI is expected to be the next version of generative AI, and obviously this is going to be a next revolution in the AI system. So next comes the vision, generative AI as an enabler of innovation. So the vision, AI as a tool for innovation. Generative AI is not meant to replace human creativity. Instead, it works like a creative partner, helping people think better, work faster, and turn ideas into reality more easily. Right. So in India, business can use AI-driven solutions. Okay. In India, business can use AI-driven solutions to grow faster, improve efficiency, and compete globally, even with limited resources. AI also enables data-driven policy making, helping governments analyze large data set to design better policies and deliver improved citizen service. In education also, generative AI can provide personalized learning, especially built for different learning speeds and languages and needs, making quality education more accessible. In healthcare, AI can speed up drug discovery, support doctors while early diagnosis, and improve patient care. Beyond this, generative AI is transforming media and entertainment by creating immersive experiences and making content creation accessible to more people. Overall, generative AI enabling innovations across sectors while keeping human at the center of creativity and decision making. Next, in the last, I will embrace the revolution of AI as the journey of generative AI from Alan Turning's early ideas to today's extremely powerful models reflects years of continuous human innovation. Educators and academicians play an important role in shaping how AI is used responsibility, and I am very much in support of Ahmed sir, as he said that teachers are the people who are going to explore this system and letting the students to know more about this. So it becomes our responsibility to go through the new technologies and learn new technologies and have to work as a leader in this field. Okay, so this faculty or they will have to guide students in understanding AI, help setting ethical boundaries, and explore meaningful ways to use these tools in teaching, learning, and research. Since AI is evolving so quickly, staying curious is essential. Experimenting with new tools, learning how they work, and engaging with the wider AI, and education community helps us remain relevant and innovative. As we move forward, it is equally important to address ethical concerns, promote fair and equal access, and keep human creativity and judgment at the center of all AI use. Generative AI should empower people, not overshadow them. Let us move ahead with confidence, exploring, experimenting, and leading together so that AI becomes a positive force for creativity, learning, and knowledge generation in the future. So, with this, I end my presentation, and I hope you all are getting the idea. And if you are having any question, you can put forward. I'll try to answer all the questions.
Thank you, ma'am. On behalf of the organizing committee and all the participants, we are thankful for this informative session. Your detailed information regarding the introduction of generative AI, evaluation concepts, and core technologies within this short stipulated time has enhanced our knowledge, ma'am. Thank you, ma'am. Thank
Yes,
you very much.
you're most welcome.
We now open the floor for question and discussions, if any, from the participant side. Participants, please, if you have any questions. Ma'am, I have one question.
Yes,
Uh,
please.
what is the flow for creating a generative AI agents? Means
Reflow?
which tools can we use and so that we can build a generative AI agent, ma'am?
Actually, these tools are already created by the big companies. As we are, you can ask like the specific AI tools, right?
Yeah, ma'am.
So for this agentic models, I have to explore because these are the I think Meta Llama is a tool that where you can ask, or there are you have to search for these tools because these tools are emerging day by day. So a
Okay.
specific tool for now I am not remembering any particular name, but agentic AI is next uh, next revolution in the AI system. I will definitely get back to you and I will explore and then tell you.
Thank you, ma'am. Thank you very much, ma'am. Thank you, ma'am. Next, we are we are fortunate to begin our next session with
Okay.
a distinguished resource person. It is a proud privilege to introduce and invite our esteemed speaker, Dr. Nandini KK. Dr. Nandini KK is an accomplished academic and researcher in electrical and electronics engineering. She holds a PhD from MIT, Mahe Manipal, with MTech specialization in energy systems engineering. She is currently serving as assistant professor at NMAM Institute of Technology, NITE, with over 23 research publications and 6 Indian patents. Her research interests include electric vehicle integration, reliability analysis of electrical networks, and smart mobility solution. She has received multiple Best Research Paper awards and an Academic Excellence Award. Dr. Nandini is a member of IEEE, Institute of Engineers, Women in Engineering, and a lifetime member of AMI and actively contributes as a reviewer for reputed international journal and conference. I now invite Dr. Nandini ma'am to kindly take over the session and enlighten us with her expertise knowledge. Ma'am, please.
Thank you, ma'am. Thank you for the nice introduction. Am I audible?
Yeah, ma'am. Yeah, ma'am.
Okay. Yes. And first of all, I would like to thank AMIE and Aditya Institute for providing this opportunity. And let me share my slides. Is my shares are visible? Is
Yes,
my
ma'am, it's
slides are
visible.
visible?
Yes.
Hello.
Ma'am, it's visible.
Yes,
Yes, ma'am,
ma'am.
it is
Yes, ma'am.
visible.
Visible, visible.
Okay. Okay. Good afternoon to everyone. Already madam has introduced about me. So I'll start with the topic, and I would like to talk about large language models, its architecture, how it has to be trained, and its capabilities in various domains. And the outline of this presentation follows with natural language processing and a brief overview about large language model, its architecture, its training process, capabilities, its application in various domains, the challenges and limitations associated with it, and the top future trends. Before starting this session, I would like to quote, language is a kind of bridge between human thought and machine intelligence. Why? Because we humans, we think, we speak, we write, and we have a lot of ideas. At the other end, machines, they don't have its own inbuilt intelligence, and they can't talk or they can't write by itself. But the data's what we feed is accessed through it. So that language acts as a connector, or it acts as a translator between humans and the machine, so that whatever the thoughts we have, whatever the ideas we have, that we can amplify it using the machine and the technologies what we have. So with this, I would like to start with AI and what is the difference between narrow AI and general AI. Because in the digital era, already sir has told, AI is like a transformative force. It is changing a lot of things in our day-to-day life. So we should know what is AI, then we can understand better what is this large language models and other models. So AI is one thing, that is the ability of computer systems to perform any task, various tasks, but with a human intelligence. And then come to narrow AI, what we have now, like Siri, Alexa, and all, they are focused on any one specific task, or they are narrowed to a some of the task, but they don't have that much of human intelligence. But general AI is one, it is provided with the human cognitive abilities, so that it can perform, or it is possible to do real time, it is possible to solve any real time problems, and also human level AI integration is possible in the general AI architectures. Next, the natural language processing is like a foundation for the large language models. This natural language processing, what it do actually, it converts, or it first it understands, and then it generates, or it acts like a human language. And it's a combination of computer system, linguistic, and the knowledge of the machine learning models. And it uses some of the artificial intelligence steps, and accordingly the human intelligence is involved at the output side. So this natural language processing is used in some of the applications, like facial recognition, speech recognition, and it can be used as a translator from one language to another language, and it can be used for sentiment analysis. That means if we want to judge the emotion of the text, positively, negative, or neutral, all those things can be performed through the natural language processing. This picture shows how LLM models are developed year by year. Actually, the first mathematical model, which is developed in 1943, that is artificial neuron, that is a foundation for all the machine learning models what we have now. And in 1994, ngram is developed, that is for the classical language tasks, that is used to perform some classical language tasks. And in 2013, word2EC is developed. From that, the future vectors are introduced. And in 2017, the most complex, the transformer architecture is developed. As we all know, whatever the LLM models we have, all are almost all are using this transformer architecture. Next, in 2020, the GPT-3 is introduced. And in 2023, GPT-4 is introduced, that has a multimodal facilities. This is limited till 2023 because this figure I have taken from one of the literature. But in 2025, and now we have GPT-5 series, and also it is expected to have GPT-6 series also as soon as possible. Once it comes, then many of the real-time problems can be solved more effectively. and that is integrated with the human level interactions. Next, what is language model? There is a slight difference between the language model and the large language models. So first we should know what is language models. The main function are the language model. It is also an artificial intelligence system that predicts the next word, whatever the sequence of sentence or the sequence we have given as input. From that input, we can predict what will be the next word. So how that prediction is done? The prediction is actually done based on the probability. So I have given one example here. The cat sat on the, in the language model, if we type the cat sat on the, then what it do, the model analyzed that takes that sentence as input data, and based on the various data already available in that model, it processes and it comes with a different answers or output like mat, floor, sofa, or any other thing, but with a different probability rates like 45%, 30%, 15%, like that. But which word is selected, that is based on the highest rate of probability. The word which is having highest probability is considered as the next word. So based on the probability, this language models, they predict the future words. So first it understands what input is given, and then it predicts the output. And the best thing is that it can be mainly, we can see that in our mobiles, when we are doing chatting and all, we can see while typing the message, sometimes we'll get that words which is based on the previous chat histories. It automatically gives that words. So that prediction is done based on the input data. Next, what is large language models? Why it is called as large? Because these models are trained with an enormous amount of data, like some billions of data are involved with this. And then from where they will take those data? Various models are available and we all are using those models, but all of them, from where they are taking those data? Actually, from the entire internet, from the various websites, books, articles, and from the research articles, and some of the data is even taken from the humans who are expert in some of the specialized fields. With them, they'll do the conversations, and those data also taken. So lot of data and lot of parameters are involved with that. That's why it is called as the large language models. So these AI models, what they do, they will understand and also they will communicate as a human language in a deep learning, in a transformer architecture. And the most commonly used language models are, as we all know, ChatGPT, Gemini, Claude, and some other models also there that I will share in the coming slides. Next, this figure shows the background of LLMs. Any LLM, if we take how it actually performs. Initially, just a minute. Sorry. Initially, the input is given as a text. Actually, the text data are used, and simply those collected data can't be used for the analysis. Before using those data, they have to do the pre-processing. In the pre-processing stage, what exactly they will do? They will clean those data because some of the text or some of the data taken from the multiple websites, they'll be having the same information. So that is not required to have the same information again and again. So that type of excess data are sometimes are duplicated data, and sometimes the low quality data, all those things is to be removed at the pre-processing stage. And then that data is taken to the tokenization. That means if you consider a big sentence, that big sentence is split into the small words, or sometimes in that word, some of the characters are taken as a tokens. For example, I'll consider as apple. That word apple itself is taken as a token, or it can be split into a character A. Just A is taken as a token and remaining part is taken as another token. So each word is provided with a special or a different token ID, and then that is taken for the pre-training process. In the pre-training, again, they will check for any of the mistakes, and then the specific task is to be performed based on the user instruction. Then it comes to the activation function. That is one of the important stage in the LLM functioning. It decides the curve fitting and its stability or throughout the process. And in that, the attention mechanism, that is also one of the major step in that. Different layers are there. Based on that, it performs whether both input and queries taken from same encoder decoder are from the different. All those things are decided based on this attention mechanism. And then it goes to the layer normalization. In that, the convergence is decided by that layer normalization. That faster convergence can be done through the layer normalization, and there are different types of normalizations are there, and also different algorithms are available for tokenization also. Each type of model use the unique tokenization and the unique normalization methods. And finally, the output is generated based on the user requirements. And this figure shows the transformer architecture. This is most commonly used architecture in many of the LLMs what we are using. This architecture is having dual structure encoder and the decoder. Decoder faces it has. The encoder acts as a reader. It takes the sequence of input data and then it makes it as a token, and that is fed to the decoder. So decoder acts as a writer, or it acts as generator of text. So in this encoder, it has a two layers or two stages. One is the self-attention mechanism. Another one is the feed-forward neural network. And in the decoder also, the same phases are there, but one additional phase it has, that is the cross-attention, or else that can be called as the multi-feed attention. So what that cross attention do, it comes back to the encoder output, and accordingly it changes, or the process is changed, and finally the output is generated at the decoder end. And this architecture, the number of layers and the number of encoders, decoders, all those things varies based on the type of LLM models, and based on the accuracy level, that number of layers are varied. And there are different types of variants are available in each type of model. In some of the models, they use only encoder models, and some they use decoder only models, and some they use encoder, decoder, both models. The best example for encoder only models is this, but they use only encoder models. And some of the LLM they use only decoder models. And for example, this T5 series, they use both encoder and decoder models. This encoder only models, what they do only understanding task and analysis task. Decoder only models, what they do, they will generate the text. But encoder decoder models can generate the, or they can provide a complex information, based on the input provided, based on the user instructions. Next, already, as I said in that architecture, the encoder has two layers. One is the self-attention mechanism. Another one is the position-wise feed-forward network. In the self-attention mechanism, all the inputs are they will verify to understand what is the context of the user, in what context the user is asking. So accordingly, in the self-attention mechanism, all the inputs are verified. And then in the second stage, in the feed-forward network, that neural network enables the different position of all the inputs, and accordingly the tokens are generated. Next, the main stage in the LLM, that is attention mechanism, as already I showed in that architecture. So in the attention mechanism, usually the dot product attention mechanism is performed. In that, what happens, a query and the key values pairing is done, and accordingly the output is generated. So the dot product happens between the query and the key values. What is the use of query and what is the use of key and what is the use of value? They all do the different tasks within that model. So query deals with what user is looking for, and key deals with what I have to offer. That means the model has to offer. And value is like the information I carry. That means finally what is to be given as an output to the user who is using that model. So based on this query, key, and values, a future vector is developed in the attention mechanism. Next is the decoder phase. In the decoder phase, it has three layers. The self-attention and feed-forward network is almost similar to the encoder network, but only thing is that they are masked, because directly they cannot generate the output and they can give the output. Before giving the output at the end, they have to be processed, analyzed, evaluated. That's why they are masked at the decoder end. And one more is the cross attention or encoder decoder attention, that is interfaced with the encoder. So it visits the encoder output, and accordingly the process is to be done. Next, in the embeddings and positional encoding, whatever the input words are given, they are converted into numerical tokens, and then the future vectors are created, and also the position for those vectors are assigned in that stage. And I have given some of the architectural view of various models what we are using. Each model is having different architecture. The first one is the GPT-1. Here we can see it has 12 layer of encoder. In that 12 masked self-focused attentions are there. And if we see the BERT architecture, it is a transformer architecture actually. The BERT base has 12 layers and BERT large has 24 layers of decoder. So it varies from one model to other model, and what tasks they want to perform and on what level of accuracy they want to give. Next, this one is a Roberta architecture. This is almost similar to the BERT because this is an optimized version of the Roberta. And this one is the most trending T5 series architecture. This is also a transformer architecture, but it has multiple layers of encoder and decoder that we can see here. Next, there are different taxonomies are available in the LLMs. And this LLM taxonomy is classified into mainly two groups. One is pre-trained model-based LLMs. Another one is the API-based LLM models. In pre-trained model-based, again, there are different classifications are there. all the GPT series, GPT-1, 2, 3, 4, 5 also we have now, and then BERT in that different versions, and others like Roberta, DistilBERT, SpanBERT, and then ExcelNet. All those comes under pre-trained model based. And in API based, again, they are classified as traditional machine learning based and then the deep learning based LLMs. But the main difference between this pre-trained model based and API based is this pre-trained model based is like they work with the local servers, and API based is like the cloud based service are the servers are required. And but as I know, people are most commonly using this pre-trained model based LLMs compared to the API based. Next, categories of data sets. When we are dealing with LLMs, the first and foremost thing is the data set. In each stage of its work, like pre-training, fine-tuning, even in the evaluation stage, we need variety of data and the quality data. So the data sets which they use in the LLM model are mainly classified into 5 types. One is the traditional NLP data sets, pre-training data sets, instruction-based fine-tuning data sets, preference data sets, evaluation data sets. So this traditional NLP data set is like, in earlier days, whatever the researchers have developed for their language task, classical language task. So those data sets are used. And in the pre-training data sets, it is a large text data which is available in the internet websites, and that has a specific structure and the patterns. And in the instruction based fine-tuning data sets, what it happens actually, these data sets perform the task based on the user's instruction. What instruction is given by the user, accordingly that data set performs. In the preference data sets, they are enabled with the human judgment, and this evaluation data sets, they are used for the measurement and systematic applications, and also for the standard tests. So there are different types of data sets are utilized in the language models in different stages. Next, this figure shows how the training of the LLMs is to be done. Actually, the LLM training is done in 4 different stages. In the first stage, data collection and pre-processing is done. Next, in the second stage, model pre-training is to be carried out, and then model fine-tuning is done. Then the model is evaluated. So first, the raw data is collected from various sources, and then that is to be taken for the pre-processing. Any duplicated data, any low quality data, all those things is to be removed. Then it is to be pre-trained. In the pre-training, the tokens are generated, that large sentences are split into the small words, and tokenization is done. And in this phase, that the architecture comes, the attention mechanism comes, and then the fine tuning is done. In the fine tuning, what user is given, accordingly the tokens are arranged, and based on the instruction, the process is done in the fine tuning stage. And finally, the text or the output, whatever generated, it requires to be evaluated rigorously, because sometimes it leads to a misinformation or false information. So that should not happen. That's why it is to be evaluated at the last stage with the specified multiple tasks, and then with respect to logical reasoning also, and then the output is displayed. So this is how the training is done within the language modeling. Next, It requires various hardware components. Actually, the hardware requirement in the LLM training is highly demanding, because without hardware components, it's not possible to build any of the large language model. So most commonly are the important hardwares which are used in any of the LLM is GPU, CPU, RAM, storage, networking, cooling and power supply, distributed computing. GPU is a major thing, because if GPU is good or powerful, then the process is very fast. As we all know, NVIDIA Tesla series GPUs are predominating, they are dominating in the market. That's why recently that market also grown like anything. The people who have invested in NVIDIA, their amount has grown like anything. If 5 years ago, if they have invested in NVIDIA shares, their amount has grown like anything. That's what if GPU is powerful, then it acts like a game changer. Then comes to CPU. CPU is a it is used for the pre-processing stage, and RAM is required for handling the various datas. And the storage, it requires enough storage to store those datas, architecture, and all other things. And networking, it requires the good and the speed internet facility to download those datas, to share those datas, or to share those informations. And also it requires a good cooling system, because while training, that LLM models get overheated, so that it requires a efficient cooling system, and also it requires a robust power supply to have a continuous power flow for all the equipments. And distributed computing is used when multiple GPUs are used. When they deal with a large language models, means the model size is very huge, then it's not good to go with a single GPU. They have to use multiple GPUs. In that situations, they have to use distributed computing hardware also. Next, the capabilities of LLM in various domains. It can be used to perform various types of tasks, like it can be used to make decisions. It can be used for any emotional intelligence works, and it can be used for logical reasoning, learning, and any executive functions. It can be used for analysis purpose, we can use. So overall, it can be used for any individual or collective task. So it has a wide ability or wide capability it has. Then how any LLM we have to evaluate? We are using the different LLMs in our works. So, but how that LLMs have to be evaluated once they have developed any model, how they will evaluate it? So first is that that is evaluated with respect to the standard benchmarks or the test functions, and also the experts in that field, where the human is taken in that loop, and also some of the simulation based evaluations are done, and also bias assessments is to be done. That is very important. Whether the output generated is bias or misinformations are created, that assessment is to be done. And also the technical interoperability is to be verified at the end. So if we have any technology, that will be having a positive side and negative side. So this large language models also have positive impacts as well as negative impacts. The positive impacts is like we can do any automation, and we can have advancements in the natural language processing. That's what the large language model do. And virtual assistance can be done. It can be used in the medical and scientific research. That's why nowadays a lot of time can be saved. And also it can be used for any personalized and customized work, and in education sectors it can be used. But the negative impact at the same time is like ethical concerns. If the data used is biased and if it is not proper, then obviously the output generated is not accurate. It leads to misinformation and job displacement, like if kind of content creation or data entry type of jobs. Obviously, these algorithms or these models do faster than human. There is a scope of job displacement also, and data privacy, especially in the medical field. The data related to the patients, that is that has to be kept very securely, so that data privacy and other regulations and accountability issues are there with the LLMs and while using the LLMs. Next, these are the challenges and the limitations which are associated with the LLM in various domains in our day-to-day life. In medical field, if we take that's what biasing and fairness. If data we don't have proper data, then it don't give a fair results. And also the privacy of the collected data. In finance sector also, the implementation is not that much easy. And in business and in industries also, there is a risk and biasing is there. And when it comes to agricultural sector, the visual data are not that much available, and there is a reliability issues. And even in the energy sector, the data training and security threats are there. And in education sector, there is a challenge of dependency, more dependency on that. And in the research sector, again, the understanding and the trustworthiness of the given output. And like that, in every field, it has its own challenges and limitation. But at the same time, in every field, we can utilize it for the better performance in any task. Next, it has various applications, but I have shown some of the top applications, real world application of LLM. It can be used for content creation, and it can be used as a translator between one language to another language. And it can be used for sentiment analysis. That means to judge the text emotions. And it can be used for screening. And if any storytelling, if you give a prompt, give a story related to this, that will give, yes, sure, I'll give, like that it will give. So it can be used for the different tasks and in different fields. And I hope in this FDP, many of us are educators. So I thought one slide I'll include, which is related to how this LLM benefit educators. Mainly, it can be used for gradings and for creating the contents, notes or any materials related to classes, and for scheduling the classes or any MSCs like that, we can use this. And one more thing I suggest, don't go with any one single model. Better to use 2 to 3 models, and then you see what output you are getting. And with your knowledge, it's better to use, or you have to decide. Then we think, what are the language models we can use? Variety of models are available. Here I have given some best 15 large language models which we can use. In that, some are free source and some are not free source. We have to pay for it, or we have to go for subscription. The top large language model is GPT, that all we know. And then Lambda, Llama, Bloom, Palm, Coherence, Claude, Erin, Gemini, and then Grok, Mistral, Falcon, Quen. All these are the different models available. We can go through it, and some are subscription, but base models are freely available. And this Falcon, Mistral, Gemini, they are all the freely available that we can go through it. Next, when we use this LLMs, the main issue is ethical concern. So what we have to look into in this ethical considerations. One thing is the bias. First, we have to mitigate those bias while selecting the data itself. In the pre-training stage itself, we have to take care. Like we have to use diverse data, and also regularly we have to evaluate those data. And then finally, whatever the output is generated, that may give a false information. That's why the one who is using, that person must have a minimum knowledge of what prompt they have given and what is their expectation. So that can be done. And then privacy issues while using the data, protect the user data, because sometimes that is related to the personal informations, and in a medical field, again, that safety issues. And also, while taking the data, consent is to be given for usage of the data. Next comes responsible AI, because as already I said, the AI is like a transformative force in this era. So this responsible AI refers to the
ಮದ್ವೆಯಲ್ಲಿ
ethical
ಮದ್ವೆ
ethic-
ದಿನ ನಾನು ಸಂಜೆ ಇನ್ನೆಲ್ಲ ಚೌಟ್ರಿಗೆ ದುಡ್ಡೆಲ್ಲ ಕ್ಲಿಯರ್ ಮಾಡಿ ಓಡಬೇಕು. 2 ಲಕ್ಷ ಇವ್ರು ಏನ್ ಮಾಡ್ಬಿಟ್ಟಿದ್ದಾರೆ, ಲಾಸ್ಟಿಗೆ ಕಿತ್ಲೆಹಣ್ಣು ಬಾಳೆಹಣ್ಣು ಅವರೆಲ್ಲ ಅರ್ಜೆಂಟ್ ಮಾಡ್ಬಿಟ್ಟಿದ್ದಾರೆ ಟ್ರೇಗಳೆಲ್ಲ ಕೊಡ್ಲಿಕ್ಕೆ. ಇವ್ರು ಏನ್ ಮಾಡ್ಬಿಟ್ಟಿದ್ದಾರೆ,
Sorry, ma'am, someone is talking in behind. Okay. And responsible AI refers to the development, deployment, and uphold of the ethical concerns. So mainly deals with the transparency, accountability, fairness, and it has to be, while designing itself, human is to be taken in loop, so that misinformation at the output stage can be avoided. Then what are the futures of LLMs where we can look into? One is fine-tuning in the specific domains. When we are dealing with any individual task, the fine-tuning, whatever stage comes in, that we can look into. And enhanced code generation, it can be used for generating the codes for our works. And then multimodal learning can be incorporated, so that the complex information can be created at a time. Image, code, text, everything can be created. And then security and safety considerations can be incorporated. And also the collaborative programming, that's like many developers working on a single project, and they can interact each other simultaneously. Such type of features can be incorporated. Then as I have gone through the different literatures, and I found some of the future research directions in this large language model area is mainly mitigating that biasing in the data collection and in the data pre-processing stage. And also optimization efficiency can be improved, and people can work on the multimodal LLM, so that the complex information generation can be done. And also the human AI collaboration, so that the real-time task can be performed performed efficiently with higher accuracy. And also it can be developed for any personal and customized task, that can also be done. So with all this, I would like to conclude as these models mainly have a transformer architecture, different layers of mechanisms, and it has a various advantages and limitations. Mainly the ethical concerns are there. With all this, it transforms actually AI from pattern recognitions into core intelligence layer for the future digital systems. But with all this, it requires a balance between the innovation also with the ethical implementation. That is the major difficulty in these models. So these are the Literatures are the papers which I have gone through, and some of the images, not only some, almost all of the images I have taken from these references. And before stopping this presentation, I would like to add two more quotes. One is, the future of intelligence lies in teaching machines how we speak, how we reason. And as we all have a notion that this AI or this technology may replace us or our jobs. But I don't think so, because AI is always a tool and we are the masters, we are the artists. We should know how we have to use that tool. So we have to use those tools effectively. That should not replace us. It has to enhance our creativity and it has to amplify our creativity and innovations. We have to use that in such a way. So with all this, I would conclude, and thank you. Thank you for the opportunity and thank you for patient hearing. Any queries, please?
Participants, please, if you have any queries.
Yeah, hello, ma'am. Good afternoon.
Yes, sir. Good afternoon.
Yeah, I have one question regarding suppose there is some medical prediction or recommendation. So how can we utilize that LLM and as well as that Gen AI in that particular perspective?
Okay, sir. Sorry. Actually, you said medical. In medical, what
Drug
exactly, sir?
prediction actually, ma'am. That is drug prediction through LLM or Gen AI.
Okay, okay. Medical related predictions you wanted to do.
Drug prediction, yes, ma'am. Drug prediction only.
That in the LLM, you can give the prompt, sir, whatever prediction you wanted to do, that prompts you can give accordingly, whether you want to generate a code or whether you want to have a text data, that will give according to your prompt. But again, it is like you cannot completely assure or you cannot completely accept that that is proper, because still there is a lot of work needs to be done. There are chances of misinformation also. So that again, based on your knowledge in that area, based on that you can decide.
Oh, actually, I am asking that suppose there is some data set. If I train that data set according to that data set, whether it may be textual data or it may be image data, according to that data, drug will be predicted and
If
this
you
LLM will
want
be.
to do predictions, sir, you can use any machine learning algorithms like linear regression models, deep learning algorithms. Those things you can use, sir. That is a really good one to use for the predictions.
Yes, ma'am. Actually, I'm trying to use the model like KNN, SBM, all those models.
Yes, sir. Yes.
Yeah. After that, it will predict one medicine, particular recommend one medicine, and
Yes.
the substitute medicine also recommended with the same same what is it is telling actually same like suppose paracetamol or
Yeah.
you can say paracetamol the composition same composition it will recommend the same composition.
Okay. So
It can be possible, right, ma'am?
yes, sir. Yes. So what I suggest, you can use the 3 to 4 models like deep learning model, reinforcement learning also you can use. And initially you can go with the machine learning models like linear regression or any other thing. And then you compare the accuracy which they have given each model. And then finally you decide or come to the conclusion.
Okay, ma'am. Thank you.
Thank you, sir.
Thank you, ma'am. On behalf of the organizing committee and all the participants, we are thankful for this informative session. Your depth of knowledge and explanation of the complex concepts with clarity made this session a memorable one, ma'am. Thank you, ma'am. Thank you very much for your presence, ma'am.
Thank you. Thank you very much. Thank you for the opportunity.
Okay, ma'am. Now we
Thank you,
will
ma'am.
conclude this session. Yeah. Now we conclude this session, and I request all the participants to join at 2 p.m. for the next session. Thank you. Thank you very much.
Thank you all participants.
I request the participants to fill their feedback through this link, which is shared in the group. Thank you all.